K, B, O, L, O. Find the surface area. No other directions. This base shape is a right triangle, so I can use these legs as my base and my height. Let's call that A to be consistent. We've been calling our base shape A. The area of A, the area of this right triangle. I know it's a right triangle because of this mark. This square mark tells me that these sides are perpendicular, which means the perpendicular distance from the vertex to the base is the same as this side. And so when I do area of face A is 1/2 base times height, on a right triangle I can use these two sides that are perpendicular as my base and my height. So 1/2 multiplied by 6 multiplied by 8, which gives me 24. Now because this right triangle is scalene, we have a bit of an issue. Oh, we have a major issue. I messed up. You need some information that you have not yet been taught. Many apologies. Oh, particularly if you struggled with this on your own first. Sorry about that. Let me teach you something pretty important that I wish I had more time to teach you, but we'll make the best of this situation. If you have a right triangle and you know that these two sides, these two shorter sides, there's a formula called the Pythagorean theorem. It goes like this: a squared plus b squared equals c squared. The longest side must be opposite the largest angle. And so the longest side is called the hypotenuse, and that's c. The two legs are a and b. So let me substitute these values and we'll calculate how long c must be. 6 squared plus 8 squared equals c squared. 6 squared is 36 plus 8 squared is 64. So this hypotenuse, its length squared, is 100. But I don't want to know the square of the length. I want to know the length. And you can undo squaring with the square root, because the square root of c squared is just c. The square root of 100 is 10. Doesn't 10 seem like a reasonable length for this side? Look, I just taught you Pythagorean theorem in like 1 minute. That's not right. That's not the right way to do that. You're gonna learn Pythagorean theorem the right way next year. My apologies for this oversight. Had I seen this coming? Wait a minute, maybe it's not too late for me to take that off of there. No, I can't take it off the notes because then the riddle won't make sense. Well, this could be good or bad. Obviously I made a mistake, but you know it's a mistakes allowed zone, and sometimes you can turn mistakes into good things. Basically what just happened is you got a really rushed look at Pythagorean theorem, and I wouldn't expect anybody to be able to understand Pythagorean theorem from that explanation, but it's an important thing that you'll learn the right way next year. Just know that this length must be 10. This dotted line, this edge of the pyramid, this side of this triangle must be 10. And so these other faces, I'm going to label them B, C, and D because they're all different. And then I'm going to sketch them. B, this one, is also a right triangle, and its legs are 12 and 8. That's B. 8 here, 12 here. So the area of B is 1/2 base times height. Area of B is 1/2 multiplied by 8 multiplied by 12. I just realized how I'm going to fix this. Rather than have this problem pop up as a draw it slide, I'm putting this video before the problem. And so I hope you'll see the video first. The area of this triangle is 1/2 of 8 is 4, and 4/12 is 48. So the area of face B is 48. The area of face C, this triangle, let me sketch it. It's obviously the hardest problem. it's got this height, which we can see is 14, and this base, which is 6. This is C. The area of C is 1/2 base times height. 1/2 multiplied by 6 multiplied by 14. Half of 6 is 3, and 3/14 is 42. So the area of triangle C is 42. Triangle D is the hardest one to see. It's over here. It's a right triangle because I can see this symbol right here. It's a right triangle with a height of 12 and a base of 10. That was the dimension that we had to calculate using Pythagorean theorem. Alright, this one is D. The area of D, or any triangle, is 1/2 base times height. So the area of D is 1/2 multiplied by 10 multiplied by 12. Half of 10 is 5, and 5/12 is 60. So this is the first polyhedron on the sheet where we have no congruent faces. And so the surface area will simply be the sum of the 4 distinct faces. Area A plus area B plus area C plus area D. So substituting those areas that we've found, we have 24 for area A, plus 48 for area B, plus 42 for area C, plus 60 for area D. I see an opportunity to associate to my advantage, which you can do with a series of addition or multiplication, of course, because 48 and 42 is 90. And 90 plus 84 is 174 centimeters squared, which is the A up here. All right, let me see what I have for the next slide. Oh boy, okay. Okay. AKBOLO, AKBOLO, AKBOLO.